Hello everyone. In this module, we are going to learn about box plots and following are the topics that we are going to discuss. Firstly, we will learn what is box plot. After that, we will see components of a box plot. Then we will learn how we create it. After that, we will see some applications of a box plot. And in last, we will learn it to create in Matplotlib. So in Matplotlib, the box plot is used to display a summary of a set of data with features such as minimum, first quartile, median, third quartile, and maximum. And they allow you to see how your data is distributed, whether it is skewed or not, whether there are many outliners. The whisker plot is another name for the box plot. So now we will discuss some components of a box plot. So box plots are based on these six components. The first component is minimum. It is defined as Q1 minus 1.5 into IQR. The next one is first quartile. It is the 25th percentile. The third is median. It is the second quartile, or we can say that it is a 50th percentile. The next one is third quartile and it is 75th percentile. The next is maximum and it is defined as Q3 plus 1.5 multiplied by IQR. And the last one is outliners. They are the points that fall outside the limits. So now we will learn to create it. So here is the diagram of a box plot. So in the box plot, the box is drawn from the first to third quartile, while the vertical line running through it at the median. So here you can see that here the box is drawn from the Q1 and Q3 and the vertical line drawn at a Q2, we call it as a median. And to plot a box plot, we start with the median and this is the value that falls in the center of our data. Next, between the 25th and the 75th percentile, a box is drawn Q1 and Q3 respectively. And the range indicated by this box is known as interquartile range IQR. Then the line is extended from the box which is known as whisker. So here you can see whiskers and this line extends to Q1 minus 1.5 into IQR and Q1 plus 1.5 into IQR or the last data if it is less than this value. And sometimes we have a points that falls outside the whisker limits. Now you can see that. And these points are known as outliers. So now we will discuss some applications of the box plot. So it is used to identify outliers and in order to see if your data is skewed, it is used, and to evaluate the data's spread or range, we can also use the box plot. So in the box plot, the x-axis represent the data to be plotted and the y-axis represent the frequency distribution. So now we will learn to create a box plot in Matplotlib. And in Matplotlib, to create the box plot, we use the box plot function of the pyplot module. And the syntax of the function is matplotlib.pyplot.boxplot. There are the following parameters that we pass. The first one is x. It take value as an array and it is the input data. The next parameter is vert and it takes value as bool. If it is true, it draws a vertical boxes and if it is a false, it draws a horizontal boxes. The next parameter is whisk. It take value as a float and it is a position of the whiskers. The next one is positions and it take value as an array and it decides the position of the boxes. The next one is width and it take value as a float or array and it is the width of the boxes. And the last one is labels. It take value as a sequence and it is used to set label for each data set. So now we will see an example to clearly understand the concept of a box plot. And here is the code in which we will learn to create a box plot. So firstly I import the important libraries. The first one is matplotlib.pyplot as plt and the next one is numpy as np. After that I define data coordinates, and for defining it in first two cases I take random.randit function and I set the value as 0 to 110 and 0 520 in respective cases, and I assign x1 and x2 variable to it. The third case I take random.normal function to create a data set and I pass value as a 90, 20 and 300 and I assign variable x3 to it. Then I want to create a box plot. For that reason I call the box plot function and I pass x1, x2, x3, a combination of a three data set to this function. And then I call the title function to add a title to the plot. So I pass box plots as a title, and last I call the show function to display the graph. Now I execute this code and here you can see that it creates a box plot. It has three box plots and in each we have a box, and in center of a box we have a median line and we have two whiskers on above and downward sides, and in third case we also have outliers. So let's see one more example. In this case, I again import matplotlib pyplot as plt library. Then I define dataset. That time I define it in an array form and I take four data sets x1, x2, x3 and x4. Then I call the box plot function and I pass x1, x2, x3, x4 dataset as a combination to it. Then I additionally call the width function to change the width of the box plot and I set its value to 0.2. Then I call the whisk function, which is the position of the whiskers. So I set it to 0.68 and then I call the labels parameter as I want to set label for each dataset and I pass A, B, C, D value to it. Then I add a labels at x-axis and a y-axis, and in a x-axis I set it as a data and y-axis I set it as a frequency distribution, and in last I call the show function to display the plot. Now I execute this code and here you can see that it shows a 4-box plot with x-axis label and the y-axis label. It also had labels at x-axis which I defined above as A, B, C, D. In the labels parameter, it creates a box plot with a box. It also has a line in the boxes which is known as a median line. It consists of a whiskers and it also has outliers. So with this we have learned about box plot, and in the next module we will learn about violin plots.